Hi, I'm about to show you two add-ins that they've been around for a while, add-ins for SymXDraw, but I've recently revised them and I thought I would make this screen cam just to highlight their existence. So the first one is a simple, or what looks at first glance to be a simple SD file viewer, but it's an SD file viewer with a twist. So it's launched from the file menu of Accelrys Draw, and it gives me the opportunity to open an SD file straight away. So I'll take the largest one that I've got here, which is this one. And it obviously loads in the records and displays them. But the twist is, and this isn't a very good example to show you, that there is an ability in here to not only load the data that's in the SD file, but also add to that if the material happens to be available on Discovery Gate. And the other feature, which is a little bit novel, is you can actually search this SD file without having to load it into a database. So I can do substructure searches and exact match searches based on just the contents of the SD file, and it's using a Cheshire mapping function for the substructure search, and for the exact match search it uses the NEMA key. So if I define a query here, and I can do this based on my knowledge of the contents of this SD file, I want to find all of the benzene rings that have a cyano group attached. I just need to change that to a nitrogen and transfer it back. So there's my query. I'm going to choose a substructure search, and I click on search. It executes the query, and I've gone from 958 records to 110 in a pretty short space of time. And you see they all have the structure that I searched for. So I'm going to show you the Discovery Gate functionality working. I'm going to swap out of this one and choose a different SD file, one that I know has some data in it, which is going to bring back some hits from Discovery Gate. So this one, the dialog itself is sizable, by the way, so I can make it a nice size to see all the data that's in here. Maybe make that a bit wider so we can see all the names. I'll scroll through to record 5. Record 5 is available, and it's in these two databases, ACD and Current Medicinal Chemistry. And you see how fast it looked that up there. This one's just checking. So the reason that the previous record was much faster was because there is, in the background, we're saving these results into a timed cache, an XML file, which stores the information about the structure and its availability. So if I go back to the record afterwards, you see it's now as fast as the previous one. It's a timed cache. That cache lasts for 30 days, after which the availability may have changed, so it will refresh the data that's held about that structure. What else is there to say in here? It's calculating a couple of extra fields here. It's calculating using Cheshire scripts the exact mass and the total polar surface area. These are fields that aren't present in the SD file, but they're added. Other things that are added from Discovery Gate are the rule of 5 violations, C-log-P, the hydrogen acceptors and hydrogen donors, as well as information like the MDL number, other names, and things like that. MFB, yeah, we've got MDL number twice because it was in the SD file, and it's also come from Discovery Gate. And obviously you have the available flag up here. Other functionality that's in here, we can do things like right click over here and copy. We can right click and copy values from the property grid, and we can create a sort of report. It's going to generate an RTF file with these 71 structures in. We can choose what records we want, and what data we want from the table. We'll just export all. It will generate a rich text file with the structures embedded as images. If you're wondering why that takes us a while, I believe it's because it's also looking up the discovery gate information for each of the records as it's doing the report. So it's finished, and now we can save that report to I'll put it on the desktop. Yeah, and save. So there, that will open in Word. And there we have a nice report with all the structures in, all of the data that's been generated. And so on. Okay, so that's the SD file viewer. And the other add-in is one that I feel is quite a powerful tool actually. So let's just add a structure here. What we're going to do is search a folder structure on the disk for chemistry. I've got this search test folder over here, which contains a number of different files. If we have a look in there, it's got mol files, SD files, sketch files, a smiles file, various docx, PowerPoints, and so forth. And we're going to search that for chemistry using this search add-in. So I'm going to do there are different types of search that we can do here, but the focus I wanted to use now is the local folder search. I can choose the folder that I want to search. I'm going to use search test. I can also choose to search up to 20 subfolders deep underneath that folder, and I can also choose what kind of search I want to do. So in this case we want to do a substructure search, and just as before, in the case of a substructure search, it's using a Cheshire mapping function to do that. In the case of an exact match search, it uses the NEMA key. So it scans through the folder and subfolders if required, looking at a list of different file types. In the case of Word documents, it will search for inline shapes, and it will find out which inline shapes are MDL draw objects. In the case of a docx file, it will also pull out CDX or ChemDraw based structures as well and convert those into mol files. Once it's pulled all the structures out, it then executes the search across this list of structures that it's found and builds a hit list, and that hit list is then displayed in the search results. So if I click on search, it goes by fairly fast. So it's looking in all those different files. It's found 10 hits. I'm still working on getting the accord functionality to work. That's something I need to adjust. It works for Accelrys for Excel based spreadsheets, but not accord yet. If I make this one wider, you'll see. So it's found a mol file. It's no big deal there. It also looks up the availability of this material on the with this checkbox here, just as the previous one did, and I can scroll through. Each of these records actually holds the same structure. So it found the Smiles file on the disk, it found the sketch file, it found the CDX file on the disk. It's gone into an SD file and found the structure in there as well. And there we have this is a doc file, an old Office 97 style doc file. Moving on, then we've got this is a newer docx file, and in this case it was an MDL object. Sorry, that was a ChemDraw. That was a ChemDraw object. There's a trick to getting ChemDraw objects out, and it only works for docx files. It doesn't work for the older doc file. I'm looking at maybe a way of generating a docx from the doc, and then we'll be able to use the same trick. But that might introduce some performance limitations. Again, it's pulled us out of a docx file, and then we have some PowerPoint files, a normal structure in a PowerPoint, and a newer PowerPoint file. And so those are the 10. It didn't. If you were paying attention, then you would have noticed that in this search test we had some PDFs in here as well. At the moment, PDFs are only searchable if they contain structures embedded as live objects. So, for instance, reports generated from Accelrys reporting with structures, the structures are embedded. You can double click on the structure and it will open in Accelrys Draw. So in those cases, yes, the PowerPoint, the PDF file search works. If the structure is just embedded as an image, then that will not work. And I can't think of any really good way of improving that situation. There are tools out there like Ostra, but for a search like this, where the user expects the search to return in a timely manner, then the idea of searching through lots of PowerPoint documents with Ostra to pull out an index of structures is probably not a good one. But that's essentially it. These are the two items that I wanted to show. Again, once you have, in this case, you can export the resulting hitset as an SD file. So we could call this hits. And a part of the content of the SD file is to include the file name. So you're building essentially an index of your folder with what structures were in which file. And that's essentially it. Those are the two items that I wanted to demonstrate. And thanks for listening.